Good morning, student. Today, with the series of linear algebra, we are going to discuss in today's lecture matrix formation of linear transformation. So, in this segment, we will discuss how to a transformation convert in the matrix form of a standard basis and given basis. So, the objective of the lecture is to know about the standard basis and matrix presentation with basis change. After this, we will discuss on some topics, some questions. Let's take first. We discuss on linear transformation. Linear transformation. We have already discussed on what is the linear transformation. If t alpha plus beta can or t x plus y can be written as t dy and and we can say t x y is equal to t x no t alpha t alpha x into the or if both equations we will combine it becomes t alpha x plus beta y is equal to alpha tx plus beta. This is our linear transformation. Now we do the question. Our first question, let's show that show that t e2 defined by t x1 x2 has x1 plus 6x2 3x1 plus 4x2 has a standard battery has a standard matrix one three then show then show then show that with respect to basis t is equal to 2 minus 1 t has diagonal matrix representation. Now, given that t equal t x1 x2 is equal to x1 plus 6x2, 3x1 plus 4. This is the linear transformation given to us. Now, the standard basis of V2. We know the standard basis. We know the standard basis. Standard basis of E2 is equal to 1, 0. So, we put 1, 0, then we get 1 plus 6 into 0, 3 into 1 plus 4. So we get 1 and now we can write in the standard E2 1, 1, 0 plus 3, 0. The matrix is become now for T0 x1 plus 6x2, 3x1 plus 4x2. So 1, 0 plus 6, 0 plus 4. So this convert in 6, 4. And in the basis form we can write like that, and this matrix become, so the standard matrix, so the standard matrix, standard matrix or is linear transformation mt is equal to 1, 3. This is the standard matrix. Now we write down with respect to given matrix, given basis. The given bases are given. Now we have the given basis is equal to 2 minus 1 and 1, 1. So T2 minus 1 is equal to, what is our linear transformation? 6x1, x1 plus 6x2, and 3x1 plus 4x2. So this becomes 2 minus 6, 6 minus, so this is minus 4. Now we write this as basis form. Bases are given to us 2 minus 1 and 1. So here we required 4, so we can 2 minus 2. This is minus 2 and this is 2. So here we can represent as minus 2 to 1 plus 0. This is equation. Now T 1 1. our transformation given x1 is equal to 6x2, 3x1 plus 4x2. This is called 1 plus 6, 3 plus, so this is 7, 7. Now we write in the form of basis, our basis is 2 minus 1 plus 1. Here we put 7, so it becomes 7, 7. This is the equation. Now the matrix, now the matrix becomes M is equal to minus 2, 0, 0. This is our matrix. Now we will show that this is invertible. This is show that the diagonal elements are variable, so this is diagonal form of matrix. The diagonal form of, so we just show that. Now move to a theorem. Theorem. Let E from B to B be a linear transform. With matrix M. With respect to a basis and with empty with respect to a basis T. So taken, if P is if P is transition matrix from basis go to S, then MT is equal to P inverse M, if Pm is equal to model matrix. The relation MT is equal to P inverse is important. Okay, now the definition. Singular matrix to n into n A and B are similar if there exists there exists an invertible matrix T such that V is equal to P inverse now. In the above example, we have standard matrix MS 136. In above example, we find standard matrix this and so 2 minus 1 basis of 2 minus 1 can be written as 2 1 0 plus minus 1 and 1 1 can be written as 1 1 0 plus 1. So P is equal to 2 1 minus 1. We find the inverse of this. We know the inverse of adjoint P. So first we find P dash is equal to 2 plus 1 is equal to 2. So adjoint A Mij matrix of perfector. So this is 1 V1 perfector of this and this is minus 1 and this is the matrix of perfector. So plus A is minus 1 and this transpose becomes 1 minus 1. This is the adjoint P. The matrix transpose of matrix of perfector has become now. P inverse adjoint A upon the value of adjoint A is equal to 1 upon 3 minus 1 we get 1 3. This is our P inverse. This is our so P inverse MS. So P inverse, what is P inverse? 1 by 3 minus 1 by 3, 1 by 3. MS is equal to we have 1 3. This is 2 minus 1. Now 1 3 minus 1 1 3 1 3. We multiply this by column. So we get 2 and minus 6. It will become 4 minus 4. 1 plus 6 7 minus 4 is equal to 2. This is our. Now multiply both. We get minus 2 0. This is our. So, so this is, you can say that MT is equal to PT MS PS minus. Also we can say, also we remember that P O F is equal to P. Now, after again, this question. So what is the similar matrix? Similar matrix means two matrices A and B are called similar if there exists an invertible matrix P such that B is equal to P inverse. So, in this question, we find the standard matrix. In the matrix, we find this standard matrix. This example we continue here. We take to solve the standard matrix. Now we are finding the single matrix of standard matrix. So if that MS is equal to this and the given bases are this. So given basis we can write in the form of basis 1 0 and 0 1. In the form of standard basis. We change here the given basis in the form of standard basis. So 2 minus 1 we can write 2 1 0 plus minus 1 0 1. And 1 1 we can write 1 1 0 and 1 0 1. Now P, here make P 2 1 minus 1 1 and P inverse is equal to adjoint P upon determinant of P. So we find determinant of P is equal to 3 and adjoint P is equal to transpose of coefficient matrix. That is the P inverse is equal to adjoint A upon adjoint P. They are not P. This is P. So it becomes 1 upon 3 1 upon 3 and adjoint P. So we find P inverse. Now P inverse MSP. This multiply by standard matrix here MS This is P inverse, this is P. Now by solving that we get MD. And you can see that this MD we also find when we make by the linear transformation. These are the same to similar matrix of standard matrix. So we can say this is the similar to standard matrix. Now we do some theorem, a statement of theorem. First, matrix A matrix A is similar to A matrix always similar to A matrix A similar to B, then B is similar to A is similar to B, and B is similar to C, then A is similar to both are. If A is similar to B, then determinant of A is always equal to determinant of B. A is similar to. These are the facts we have to remain in because these are the facts asked in the competition exam. Similar to B, then determinant of A is equal to determinant of here. If A is similar to B, then trace of A is equal to trace of Z. If A is similar to B, then A की power n, okay, A की power n is also similar to B की power, means the matrix multiplication A square, A cube, A4 is also similar to B1, B square, B cube, 7. These are if A is similar to B, then A is invertible. If and only if B is invertible. In case inverse is similar to zero. Means the similar matrix have the same properties as given matrix. If A is similar to B, then A is invertible. If and only if B is also invertible, and the A inverse is similar to B inverse. So we prove one by one. We take first, since A can be written as A, so it can also written as I inverse AI. So A is similar to matrix. So a matrix always similar to itself. How we can show that A can be written as AI is equal to I inverse AI. So A is invertible. Here this is the definition of invertible matrix and inversely similar matrix, that there exists a matrix P if A is similar to this if P inverse A. If we can write in the form, then B and A are similar matrix. So A is similar to A. Second, if A is similar to B, then P inverse AP, P inverse P inverse is equal to, can be written as P inverse AP, P inverse. That means is equal to. So if so, so we can write A is equal to P inverse P inverse and naming P inverse here work as. So, so B is similar to. So that means if A, so we conclude that if A is similar to B, then B is similar to C. B is similar to. Now C part we take if A is similar to B and B is similar to C. So if B is equal to, we can write B and is equal to Q inverse P. So we put the B value of B is equal to C is equal to Q inverse P inverse P. So C is equal to QP, or we can say that PQ inverse and the product of two matrix. Product of two matrix is also a matrix. So we can give it name. So we can give it name like Z inverse. Z inverse, and Z is the matrix product of P. That is the matrix product of P. That means that means that means A is similar to or C is similar to. Okay, student. So these three theorems we have done today. The remaining facts we will do in the next lecture. But I explain you again that similar means A similar to B or B similar to A. It can be right in this form. Okay. So now B is similar to C. So C can be written as form of this. Here we put the value of B. So P inverse AP is Q. So this is become, we can write PQ inverse. So this is can be right hand. So we can say that A is similar to cement. Okay. Now the fourth one is if A is similar to B, then determinant are equal. These facts are very important with respect to competitive exam. So if A is similar to B, then determinant of A is equal to determinant of. So here we see B is equal to P inverse. So determinant of B is equal to determinant of P inverse. So determinant of P inverse, determinant of A, determinant of. That means we can say determinant of A, determinant of P inverse, determinant of P, and this is become 1. Determinant of A is equal to become 1 upon determinant P. Cancel. We found determinant of P. So determinant of B so these are some facts and theorem we have to wear. Now we move to our quiz. Which is the correct statement? Linear transform can be represented in matrix form. So we know today we have do the exercise that linear transformation is written as a standard matrix or even basis matrix. So A is the right option. Rank of matrix equal to the range of T. Range of T means the if we remove the dimension of kernel, then we get the range of T. So A and B both are right option. So D option is the right, that A and B both are right. Which are the usual basis for E3? E3 has the element in the form of three tuples. So 0, 1 and 1, 0. 1, 0 and 0, 1 is the basis of when the tuples are 2. Number of tuples are 2. So the A is the right option because the tuples are 0, 1, 0. So A is the right option. What is the Txy? 3x plus 3y and 3x. This is the LT. Absolutely, this is LT because when we have put 0, 0, we get 0. And alpha x plus beta y, when we do it, then we get the alpha tx plus beta ty. So T is the right option. Which is the usual basis of E3. The E3 have the three tuples, but here all are the three tuples. But the tuples in the form of 0 and 1, and 1, 0, 0 in x direction, 0, 1, 0 y direction, and 0, 0, 1 in the z direction. The three direction, the remaining axes are coordinate of axes are 0. So 1, 0, 0, 0, 1, 0, and 0, 0, 1. This is the right option. So option C is the right option. So because we can form all the element of E3 by this basis. So this is the right option. Okay? Which is the right option? C. Because some students are confused that all this set have the three tuples, but the basis means we can make each element of the set made by the basis. So by A option we cannot format other element, B cannot make other element, but C we can make all the element of A3. So the basis of A3 is C. Which is the true statement? Identity operator is reality 0 transform is linear and non-inverse. So identity element Tx is equal to Tx is equal to x. This is the linear term. Tx is equal to 0 is the 0 transform. The both are the condition are satisfied. So we can say both are the right option. So thank you very much, students. Focus on the linear algebra. Thank you very much.